All right, here we go with 10-3 Arcs and Chords. So, corny joke of the day, not to be confused with harpsichords. I don't know. That's just where my brain was when I wrote this. Okay, let's get into it. There's three properties. All right, first property. In a circle, two minor arcs. Okay, remember arcs are the portion of the circle, the round part, right? Just a portion of that circumference. Okay, so two minor arcs are congruent, the same measure, if and only if their corresponding chords are congruent. Okay, so let's look at it. What that's essentially saying is it's saying that if we have a circle, okay, and then we have an arc here, okay, notice I got a tick mark, and then an arc here, notice I got a tick mark, then these are only the same if those chords are the same. So this portion here is only the same if this is the same length as well. Okay, and these are kind of work back and forth. You could also say that if these two lengths are the same, those two lengths, then that is also the same. Okay, the same measure. All right, and that's it. So basically what it's saying is, and notice these are supposed to be like the same circle. Okay, but it's saying the measure of arc AB is equal to the measure of arc CD. If that's true, then it's also true that AB, the chord, okay, notice same letter, right? AB the chord. So AB the arc, that's this, but AB the chord is this. Okay, so they correspond in this regard. Okay, that's that property. All right, property number two. We'll see all these in action when we, look at some examples at the end of this. Okay, in a circle, if a diameter or radius is perpendicular to a chord, all right, so perpendicular, right, intersecting at a 90-degree angle. So I want a diameter intersecting with a 90-degree angle at a chord, okay? If that's the case, then it bisects the chord, splits it in half, splits that chord in half, and its arc, okay? So let's look at it. We have this. If, okay, a radius is what this one is, right? This is a radius. It could go all the way through, all right? It could go all the way through if we wanted it to. But it's not in this one. So anyways, this radius perpendicular, okay, I've got my 90-degree angle, so I have this, first part checked off. Then if that's the case, then it bisects that chord. In other words, this and this end up being the same. So this line comes in here, and because it's perpendicular, it comes in here and splits. So this is the same as this. Okay, and then note, it also says it bisects the arc. So we should also add that this and this will be the same. Okay, and that's going to be, let's give this a letter. That's going to be, go with D here. All right, that's going to be arc AD. Measure of arc AD is equal, since to measure, to arc DC. Okay, so recap. If we have a perpendicular line here with the radius, this and this is the same, but also this and this are the same. Okay. Cool. And then note again that, 1 matches up with 1, right? That's the same length. This is the same measure of the arc. All right, that is property 2. Property 3. Okay, in a circle, two chords are congruent if and only if they are equidistant from the center. All right, so two chords are the same if and only if they are equidistant from the center. So we're trying to show that these two chords are the same, right? The chords have endpoints on the circle, right? So B and A, those are points on the circle. If I were to connect them, that makes a chord. All right, these are the same if they're equidistant from the center. So notice, I've got the center here. They are the same distance. Now, this one's a little bit weird because you might be wondering why that right angle's there. Well, if we were to just connect, if I asked you to connect that this point to this line, maybe you connect it like over here or something. But in order to find the distance from a point to a line, you have to use that 90-degree distance, okay? So the distance here, that right angle is important, all right? But if, the distance from the center, if that's the same, then this is the same, these chords, okay? And again, that's, this portion here, okay? So that's another property. This one goes back and forth as well. So if you have the chord being the same, then that chord, right? If you have AB is the same as CD, then you have these distances the same. Okay? Those are the three properties. All right? let's look at some examples and kind of talk about the problems that arise when we have, the problems that use these properties. Okay, let's do it. All right, let's get some paper. Okay, and maybe let's zoom in a little bit. Got these printed out, nice and cut out this time, so it's kind of fun. I don't need this. All right, zoom in. Get a little focus. All right, cool. Okay, so let's look at what we have on this particular one. Okay, well, first of all, I see that these two arcs are the same. Okay, so this arc, right, it's the same because of that tick mark. Right, that's what I notice. Okay, and then this is the same again because of that tick mark. Okay, so in other words, the arcs, these two arcs, are congruent. Well, what we learn about the arcs being congruent, okay, is that if two minor arcs are congruent, then the chords are congruent. Okay, so now we know, all right, that the chords are the same. Well, because we know the chords are the same, all right, and let's go ahead and label this as, number 1. Okay, because we have that, we now know that 2x plus 4 is equal to 18. So I can just go ahead and write 2x plus 4 equals 18. And I have that equation, and from there, I'm just using my algebra skills to find x. So we want to get this by itself first, the one that's attached to the x, and then we will subtract 4 on both sides in order to do that. Okay, so 2x is equal to 14. And then a last step, I have 2 times x is equal to 14, so I need to divide. Right? That's what we're doing. We're doing 2 times x, so how do I get rid of that 2? I divide it. Okay, right? We're always doing the opposite in order to kind of undo the property, or the operation. Okay, the operation. All right, so we're canceling the 2's here, and we end up with x is equal to 7. All right, and there's that one. Okay. Let's get a little tape action. Pause it so I don't waste y'all's time. All right, so there's that problem. Okay, number 2. Number 2. All right, second problem. Here it is. Right here. Okay. All right. So on this particular problem, okay, we want to look for things that are the same. Okay, we want to look for things that are the same. So what we have that's the same is we have these 2 9s. Okay, I have this 9 and this 9. Right, those are 2 chords. Right, chord 1, chord 2. Well, what does that mean about the arcs? Well, that means that the arcs are the same. Okay, so let's look at this one. Right, earlier on this one we had that the arcs were the same, and we showed, and we now knew that the chords are the same. So this is kind of the opposite, right, of that one we just did. So we know the chords are the same. Well, that means that this is the same as this. Okay, so that portion is the same as this portion. Well, we know this portion. We know that measure. It has it as x. Okay, so since just this portion is x, well, that makes just this portion x. Okay, so let's look at what we have. We have this is x, and this is just this portion is 90. Okay, so the question might be, how do we find x here, right? Well, let's think about it. Okay, this portion's 90, this portion's x, this portion's x. So it actually goes all the way around, right? We start at B, okay, then we go to C, that's 90. We know C to A is x, and then A to B is x. We're all the way back to B. Okay, so we traveled all the way around the circle. Well, how many degrees are in a circle? Okay, 360 degrees, right? So from here, okay, we know that x plus 90 is equal to 360. Okay, we know that that has to be the case because it travels all the way around the circle. Okay, so it has to be, and these are all in degrees. Okay, degrees. So that has to be the case that, one portion plus another portion plus the rest of it has to equal 360 degrees. Okay, so we've got x plus x. Well, that's 2x. Okay, 2x and then plus 90. Okay, equals 360. All right, great. We've got our 2-step algebra problem from here. Okay, I'm going to again isolate the 2x. So then minus 90, I've got 2x is equal to 270. That's what that is. and then we would divide by 2. Okay, we're undoing the multiplying by 2. Okay, so we've got x is equal to 135 degrees. Right? And you can test that, right? I don't do that a lot in these videos, but you can certainly test that, right? 135 plus 135 plus 90, 360. Let's just test it out, right? Just as a reminder, as what we can always do with algebra, right? So 135 plus 90. What should we expect? Right? X plus 90. 135 plus 135 plus 90. That should give me 360. Perfect. That's what it does. Okay? Beauty of algebra. All right. Number 3. Let's tape it. Pause it again. Number 3. Here we go. Okay. Here it is. All right. In circle R, TS is 21 and UV is 3x. What is x? Okay. Anytime we see things like this in a problem where it's like TS is equal to 21 or UV is equal to 3x, label it. Find those spots, label it so we can see it, right? Geometry is a visual class. Okay, so we've got TS is equal to 21, and that is this entire length as 21. So that's a little bit of a tough one, but something you can do is like kind of mirror it, right? And then just put 21 there. Okay? And then UV is 3x, so U to V, 3x. So something like that, right? Where we have, we're connecting this length. That length is 3x. Okay, so what is x? Well, let's look at this one. So this time I have the center, okay? Then I have a right angle, center, right angle. Then I have that there's a 6 here, and there's a 6 here. Because that's the same length. That's like saying that, this chord is equidistant, 6 and 6, from the center. That means that these two chords are the same. All right, and that is property, for us keeping track, that is property number 3, okay? Where we were saying, right, like this length and this length are the same, therefore this and this are the same, okay? And it's good to have that right angle there. It's necessary, actually, to say that they're equidistant. All right, so we've got 3x is equal to 21. I was going to say, too, this is actually a one-step algebra problem. Okay, so I've got 3x equal to 21. From here, we got to think about what we're doing what we're doing to x. 3 times x, so in order to get rid of it, I'll divide it. Divide. X is equal to 7. Done. Okay, that's 3. All right, example number 4. So we've got another circle, right? We're in our circle unit. We've got circle Q. All right, we've got CD is congruent to CB. Okay, so that's this right here. It's congruent to that. Something to keep in mind. GQ is x plus 5. We have information, right? Let's label it. Maybe you could, draw something like that. We've got that is x plus 5. Okay, and then we've got EQ, E to Q, this right here, is 3x minus 6. So there we go, 3x minus 6. Okay, and we're just looking for what is x here. All right, so we're using the property, we're using some algebra with it, okay, but we essentially know that because this chord and this chord are the same, right, from here, because we know that there, that means they have to be equidistant from the center, okay, which again is using property number 3. So that's like this one, right? We're saying that AB is the same as CD. That means at this point that line segment right there and this one are the same length. Okay? So that means we know that x plus 5 is equal to 3x minus 6. So it's an algebra problem. Okay, we'll just go ahead and set up the algebra once again. We've got x plus 5 equals 3x minus 6. Okay. Sometimes you're going to see, the big one on the right. This is what I mean by big one is this is the side of the equation that has the most x, right? This is 3 times x, and this is just x, okay? What I like to do, me personally, is subtract the lower one. So I have x minus x here, minus x here, okay? The reason we do that is because we don't end up with a negative if that's the case, all right? At least most of the time you won't. Okay, so we've got subtracted over here So that means we're just left with 5. All right. Over here we got 3x minus x. So I had 3 x's. I'm taking away one of those x's. So I have 2 x's. All right. And then minus 6. Okay. And 2 steps from here. But we can, get rid of this. We want to get that by itself, because if we can do that, we just divide by 2 and we're done. So we're going to add 6 here and then add 6 here. So 5 plus 6, that's 11. 11 is equal to 2x. Okay, I'm not going to freak out. Okay, 11 isn't evenly divisible by 2, but it could be a fraction. Okay, so we'll divide by 2 on both, divide by 2 on both, and we get x is equal to 11 over 2. I'm going to tell you right now, that's a perfectly fine answer. Okay, if you wanted to leave it like that, it's great. Okay, moving forward in math, it's a good thing to do actually every once in a while. It's less work, right? Just 11 over 2, leave it. Okay, but I know we're more comfortable with decimals typically. Okay, so we do have that this is also equal to 5.5. That's number 4. One more.